Hello, welcome back. It is Catwoman Casus here today to teach you about probability. I'm very excited to continue this lesson. I think this is one of my favorite units of the whole year. We are going to take a little bit more notes today. We're going to learn about the notation that we use for probability so that you guys will be actual mathematicians and be able to use all the right mathematical notation. Let's get started. So probability, which we already went over, looking right there, is the probability of an event happening is the number of favorable outcomes, so that event happening, what we want to happen, over the number of possible outcomes, the total. A two-way table, this is just review, is a way to organize data about two categorical variables. Values of the row variable label the row that run across, and the column goes this way. That's it. So it's just two ways. Here's an example. This is looking at all the students in a school. It's a middle school, so they only have year 7, 8, and 9. So those are all of the possible options. Most of the problems we're going to see work in a gender binary system. So you'll see like boys and girls, meaning that those are the only options, and that would be the totality of it. Obviously, if you make your own problems, feel free to also create an other category in there. Remember that the number down here tells you the total of the people in year 7. This number right here would tell you only the girls that are in year 8. And the number over here always gives you the total of everyone together, which is all of the green ones right here added together would equal 204. Or you can add the total of boys and girls, or you can add the total of year 7, 8, and 9. Fabulous. Okay, so now we're going to do a little problem together. Today we're going to learn how do we make our own two-way frequency tables, and that's what you're going to be practicing. So in a class of 25 students, 13 have a brother and 10 have a sister. I'm going to use my highlighter tool. Okay, so I know there's 25 total. 13 have a brother, 10 have a sister. And there's 2 students who have a brother and a sister. What's the probability that a student in this class does not have a brother or a sister? Okay, so now let's start getting this data together. So the first thing I want to do is we're talking about brothers and sisters. So you either have a brother or you don't have a brother. So it's not brother or sister. You either have a brother or you don't have a brother. You have a sister or you don't have a sister. And then these are your totals down here. Okay, I'll write that in, total. Oh, there we go. And I'll write it in right here. Okay, perfect. So apparently it doesn't like that, total. I'm going to write right here. I don't know what's happening with that, but I'm not going to stress. Perfect. Okay, so I'm going to make myself a little bit smaller. And we know that the total number of students altogether is 25. So that goes in my bottom right corner. That's going to be right here. That 25 is everyone together. 13 have a brother. So I go to brother and I go to the bottom because it's the total of brother, and that's 13. 10 have a sister. So I go to sister and I go all the way to the total of sister, and that's 10. And 2 have a brother and a sister. So I go to where brother and sister meet, and that's going to be 2. Now to find the missing boxes, right? If 10 have a sister, how many don't have a sister? That would give me 25 total. Well, I can just subtract that. 25 minus 10 gives me 15. If 13 have a brother, how many don't have a brother that together make 25? So I just subtract that, and I get 12. If 2 have a sister and a brother, and there's 10 that have a sister total, how many have a sister but no brother? Well, 2 plus what is 10? Really, 10 minus 2 is 8. 13 minus 2 gives us 11. And then lastly, you can go either direction. 15 minus 11 is 14, or you can say 12 minus 8. Now the question was the probability that a student in the class does not have a brother or a sister. So I'm going to look at no brother or sister. That's right here. So my probability would be 4 out of 25. And that's how I create my own two-way frequency table. Awesome. Now we're going to think about how this relates to the real world. Here's our real world example. And this is actual data that I got from the internet of current values as of April 25th of positive cases of coronavirus in New York City. Governor Cuomo has recently conducted an antibody test on 3,000 New Yorkers to determine how many New Yorkers have most likely been infected with coronavirus. So this just happened a few days ago. They found that 21% of the people tested had antibodies, meaning that they had been infected with coronavirus. But most of them never had any symptoms. So we're going to see how this data is quite different from the confirmed positive tests that we've had. Because what's happening is a lot of people who were sick weren't able to get tested, or a lot of people were but had coronavirus and never exhibited any symptoms. That's why it's important that even if we're healthy, we stay home, because we could potentially be carriers even without knowing it. So here's some data that was put out by age group, because we've been hearing about how this affects different age groups in different ways. So this, again, I rounded some of these numbers to make them a little easier to use, but this is all the real data. There's approximately 8,632,000 people living in New York City. So in my table, I think if that's the total number of people in New York City, where is that going to go? Well, we're only talking about New York here, so that's going to go in my total. So I'm going to put that in down here. Okay. Of the 1,783,000 New Yorkers between 0 to 17 years of age, 3,361 tested positive. So that means that this number is how many people are in New York in that age group. So I go to that age group and I'm going to go to the total and put that in. And in that group, 3,361 tested positive. So still I have to stay in that line, and I'm going to put in the tested positive 3,361. Then I go to my 18 to 44 age group, and it tells me that this many people tested positive, 56,000, 474. And then 3,437,526 did not test positive, meaning that some tested negative, but most were just never tested. So it doesn't mean that they didn't have coronavirus, it just means that they were not tested for it. In the 45 to 64 age range, there were 56,428 people that had positive tests. And then in the 65 plus age range, 1,205,360 did not test positive. So 1,205,360 did not test positive. In total, there are 152,904 confirmed cases. So that's, I go to my test positive, and that's all of them together. So that's 152,904. So now I have to start filling in the gaps. So I'm going to go in a different color just to make it easy to look at. And the easiest gap I can see is right here, right? So I just say, oh, all right, well, if I added all four of these together, it would equal the total. So I just need to subtract. I can add these three up together, these three, and subtract that from the total. So I do that. Plus 56,474 plus 56,428. When I add it, I get 116,263, and then I subtract that from the total, and that leaves me with 36,641. Okay, well now I can go in this guy, figure out this one, because I can just subtract the total minus that. So I take that total and I subtract 3,361, and that leaves me with 1,779,639 people that did not test positive. Okay, let's keep going. Oh, I have the 2 here, so I can find my total just by adding them together. So I add these two numbers together. And I get a total of 3,494,000. That's how many people in New York City are between the ages of 18 and 44.
Can I keep going like this? I can also find this total the same way, just adding up the two numbers. and that gives me 1,242,001. And again, I can find this guy, because I take the total and subtract that. And I get 8479096. Yeah, that makes sense, okay. And then I can just keep going. I can add up these three and subtract it from the total. And I get 2,113,000. And the last one right here, I can just subtract 56,428.
So this is what you always want to do first, is complete everything in your table. And now you can find all the probabilities that you need to. So now the first thing says, what is the probability that someone in New York City tested positive for COVID-19? Well, all I'm going to look at here is I'm going to say how many tested positive, that's this guy, and how many people are in New York City. And that's how I'm going to write my probability. So it's just how many tested positive out of the total number of people. Okay. But what if I wanted to actually find out what's the probability that someone over the age of 64 tested positive? Well, now I'm going to change things up a little bit because I'm looking only within the people that are 64 years old. 65 or older, because they're over 64. And in that group, I want to know how many tested positive. So now I'm going to say, well, this is the number that tested positive, but my total is only in that group now. So it's going to be 36,641, but my total is how many people are in that age group. Okay. How can I compare these numbers though? They're really hard to look at. So I'm going to just divide in order to get a percentage or a decimal. So when I divide this, I get 0.0177, and I convert that to a percent. So that's approximately 1.904. Okay. 1.77%. Then 36,641 divided by 1,242,001. This now, when I divide it, I get 0.0295, which is approximately 2.95%, telling me that in that age group, there's a much higher probability that somebody's going to test positive than out of all the people in New York City. This is what's called conditional probability. Conditional probability is the dependence of events is defined by the probability that an event will happen given that some other event first occurred. So pause the video, write that down. And what that means is it's the probability that someone tests positive given that they are already in the 65 plus age group. So you are setting a whole world parameter saying I'm now only looking within this world. So I have a new total, and that's where I'm going to find my probability.